This paper was presented at the JCT Traffic Signal Symposium 2024, thanks to our media partner Highways News, and sponsored by AGD Systems, Four-Way Consulting, Traffic Group Signals, Smart Micro UK, TRL Software, PTV Group, Census Networks, and Starling Technologies.
Right, good afternoon. So Cheshire East contracted us, SWARCO, to upgrade a number of junctions to ImFlow. There we go. So we have three areas. In the northwest there, we have Dunwoody Way, which is a pair of junctions very closely spaced, and they're treated as an isolated area. And in the south there, we have Nantwich Road, which is in the southwest corner, and to the east of that, we have Crewe Arms. So there's some very, very clear goals there. So the plan was to increase capacity at Dunwoody Way, up there in the northwest. And if we zoom in on Nantwich Road and the Crewe Arms roundabout, so the Crewe Arms roundabout has had problems with flow, and that's caused queues all the way back down Nantwich Road going eastbound. So there's a very clear goal to address the problems on the roundabout, and hopefully that would reduce the queuing and improve journey times along Nantwich Road going west to east. And obviously there's a goal there to have the whole area under adaptive control. So previously, up until now, it's been running under VA.
Oh yeah. Them goals there were our initial goals. To be honest, we needed to increase capacity. That's what the client asked us to do. We needed to improve flow at Crewe Arms. We had a lot of blocking of the roundabout, so we need to keep the roundabout moving. There was a narrow point between the roundabout and the rest of Nantwich Road, which was causing us a lot of problems, both onto and off the roundabout, caused by a couple of crossings there as well. And overall, just make all the drivers happy. Just get them through there. It's a town centre environment. A lot of shops. It's the main through route of Crewe. We do have a bypass, but no one uses it. Everything goes along that route from HGVs to school kids in the morning. Future goals. This is what we really went for ImFlow for, was the ability to prioritise the different policies with the policy sliders. The highway doesn't belong to the driver anymore. There's multiple users of it. We all want to give them the same chance. Changing policies with local authority are constant. In the last 3 years, we've seen it go from active travel to air quality back to active travel. Trying to keep everyone happy is extremely hard. We felt that the use of these sliders in the future would help us justify what we're doing with the timings that we're setting at the junctions. But that is the future. The funding for this was just to get the traffic moving and provide adaptive control along the route. Talk about CITS. Oh, sorry. And make sure that the CITS compliant for the future.
So a few words about ImFlow. It's a distributed adaptive optimiser. It actually optimises individual junctions and does a very good job of that, I believe. But it also coordinates junctions, and it manages to coordinate junctions without locking the cycle times in the way that Scoot does. So the coordination happens without compromising the individual junction optimization. It allows more flexible phase and stage transitions than traditional methods. That potentially offers more green lights time. We'll see later if that worked or not. And in terms of what's required, in terms of equipment, we just needed an external application control unit, which is just a 3U outstation, if you like, which sits next to the controller. And it needs site-to-site comms. So the way that coordination happens in ImFlow is each junction talks to its neighbours, but they're not actually talking to any central system, so it'll run without a central in station, but they do need to talk to each other, and they share a lot of information. It's quite a rich data exchange between traffic light controllers, much more than the sort of simplistic linking you get with MOVA, for example. So hence, I'd say that probably the coordination is better than you would get with MOVA. The individual junction optimization is probably better than you'd get with Scoot. So it's sort of somewhere in the middle, it's a compromise. It's got its use cases. So how does ImFlow address the future goals that we're looking at? So it has a policy-driven base, if you like. So you can set up rules about what can be prioritized. You can use the sliders. So the sliders could be at a central in station, so they're not needed to run the system, but they can be used to remotely configure it, or you can go to each controller and configure them that way if you'd like. But the policies can be things like focus on flow, or focus on stops, or focus on delay. And you can also give different weightings to different vehicles, so you can prioritize HGVs not stopping, for example, if you're interested in environmental benefits. You can prioritize active travel. You could give priority to a particular route over others. So this main corridor, for example, we could give priority to the Nantwich Road and Crewe Arms roundabout corridor to the disbenefit of the side roads if we chose that was the policy. It has CITS interfaces. This has been proven as part of the Talking Traffic project in Europe. So ImFlow can output green light speed advice, and it can also accept priority and connected awareness messages from floating vehicles and make use of those. So we've not done any of this so far, but these are the aspirations and what we'd like to do next in Cheshire East. So this is where we believe ImFlow sits in the evolution of traffic control. So over the years, we've gone from fixed time control, we've gone to fixed time, but with plans selected by time of day or whatever. They're semi-adaptive or actuated, as we also call it. Then we have real-time adaptive, such as Scoot and MOVA. Then policy-based adaptive, such as ImFlow. Then beyond ImFlow, you have something like ImFlow incorporated into a whole CITS ecosystem. So if we look at the challenges, this is from Google Street View last year, in fact. This is Nantwich Road. As you can see there on the left is Crewe train station, a very busy train station, particularly when trains pull in or they're due to leave. The traffic there, as you can see, is quite heavy. The road is narrow, so we've got one lane in each direction. What you can see here is the road going over a railway bridge. So there's no scope to widen the road to put in extra lanes, so we have to make the best use of the road space that we've got. Also there you can see there's a puffin crossing in the foreground right outside the station, and you might just be able to make out one a few metres further down the road as another puffin crossing. So these are the challenges. Those crossings can be quite busy, obviously, with people trying to get to the station. So it's a very busy stretch of road, and we've done counts previously, and we reckon there's up to 800 vehicles per hour going eastbound at peak times. Do you want to talk about detection?
Yeah, we had a lot of old scoop loops, which were no longer working. Very basic detection, to be honest. Everything was running VA. It had run fixed time UTC in the past, but we'd had comms issue. We had some very old comms along there. We had, prior to this scheme update, to do it with a mesh system, but before COVID, we'd taken the decision to take it off UTC, and we felt it wasn't needed over the COVID period, and being cash strapped is a way of reducing our revenue. It's an extreme, like I said, it's an extremely busy route. It's crossed by roads into the town centre, although it's a very busy shopping road itself. Two of the main routes into Crewe town centre from the south both cross it, which caused us problems. There's a 20-mile-an-hour zone with sinusoidal humps forming part of it. There's cycle ways along it. There's on-street parking along it, and there's a lot of railway terraced housing streets joining it. So, yes, a very busy route.
And one other challenge was there's no CCTV or traffic cameras there, so it's very hard to see what's actually happening. So lessons from the detection. The existing inductive loops work very well. We had problems with a single video detector. This has nothing to do with ImFlow or even that particular video detector, but it was something that worked very well for VA operation. But for anything like ImFlow or even MOVA, you actually need an accurate Q model, and that needs to be able to have accurate counts in multiple places. And we were actually trying to get too much out of a single camera, trying to cover multiple detection zones. So we sort of learned from that. So something that works for VA won't necessarily work for an adaptive optimiser. So the successes, we said we talk about the challenges and the successes. So Jason, would you like to talk about anecdotal feedback?
Yes, funding was very low for these. So there was no pre or post monitoring as such. We've relied so far on customer feedback. They're the ones who use the routes. It's all been positive. A few people at work in passing have joked that we've managed to get rid of all the traffic wherever we put it. And the proof in the pudding is we haven't had a single complaint. Usually we change something and the phone doesn't stop ringing, the emails don't stop coming in. You can drive down there now. Peak times, it's still congested, we agree, but the length of that congested peak is vastly reduced in the morning and the evening. The lunch peak, which caused us problems in the past, has near enough disappeared.
And we outsourced the software configuration and testing to our Dutch team, and that rapidly sped things up. We've been trying to do it in the UK. We were duplicating testing. We were going around in circles in a sort of cycle of testing, software improvements, more testing, and we've just cut all that out now. It's quite a slick operation, I think. Also part of the configuration process is simulating or running microsimulation in Vissim, and that forces you to take a deep look at what's actually happening. So going back to Dunwoody Way, which is those two junctions in the northwest, they've been running fixed time plans because of their proximity and the short internal lane stacking space. Our simulation showed that right turning traffic could actually block the junction, which is something we hadn't been aware of in real life, and that enabled us to add a stop line congestion measure to overcome that, and I think that's actually working well now, isn't it, those two junctions? So as we said in the white paper that we submitted, we didn't have any before and after data, but after submitting it, I had a chat with a nice gentleman, Inrix, who kindly offered to provide us some historic journey time data. This is actually invaluable because they've got historic data across the country. This is floating vehicle data, if you like. And they can pick any point in time. So we picked the month before we did any work there and the month after. So this gave us data from January this year and then data from June this year from the same stretches of road as a like-for-like comparison, which is invaluable. An overall journey time improvement over VA is what we saw on the busy links. The less busy roads, there were either smaller benefits or the impact was mostly neutral. So here's where I'm going to show you some graphs in a minute of the comparisons. But obviously you've got the west to east journey time to the roundabout, which is around about 4 minutes. You've got the traffic going south down Mill Street where it joins that road, traffic going north from South Street, and also traffic going from east to west along Crewe Road. So looking at how improvements on one way affect traffic coming in the opposite direction or don't. So Nantwich Road is one I did a bit of analysis on. A big improvement in rush hour in the morning there. So there's about a 40-second improvement in journey time over a 4-minute journey. So that's 16-17% improvement. Using the DFT figures for value of travel time savings, which is £12.60 for an average car, times those number of hours in a year, it's about 40,000 or so. That's just for that one bit. There's other savings as well. So just puts it into context. If you want to consider, is it a worthwhile improvement or not? I think that suggests that it probably is worthwhile. So Mill Street southbound, this is the road going obviously north to south. It forms a crossroads. General improvements there throughout the afternoon. So the orange line obviously is from June. The blue line is from the earlier work in January. So that's two arms of the crossroads, and this is the third approach to the same crossroads going south to north, and again, similar improvements there. And this is the Crewe Road westbound into the roundabout going the opposite direction. You can see even that's generally improved throughout the day. So, our conclusion, the stated goals, I think, were met. I think Jason would agree. The flow's improved with no obvious detriment to safety or to the surrounding roads. ImFlow's been live since February at the Crewe Arms roundabout, so we're pretty confident there's no surprises going to happen there. And us, SWARCO, we're happy that this has been a sort of successful pilot of ImFlow in the UK, so we're happy to take orders for it from other customers.
Next steps. Excuse me. We've already specified ImFlow at other junctions and along other corridors in Cheshire East. One of them's just waiting to be switched on now. So, we've even specified it for developers. The next bits are going to depend upon future funding. Darren, we'll be waiting for your talk later. We'd like to study the benefits properly, especially those connected with the policy sliders. That's the ultimate reason why we went for ImFlow beyond everything else. We're very interested in how the policy sliders will work and how we can use them as a small authority. We want to connect it to ImFlow Central so we can set these sliders by time of day, day of week, things like that. We're interested in CITS interfaces and how we can use them in the future. And it says Vivacity AI cameras there, but other detection as well, air quality detection, blue light detection, things like that. We want to use as many sliders as we can to give us as many tools as we can to find the ultimate graphic equalizer setting, if you want, for them sliders that makes all our customers happy.
Thank you very much indeed. Thank you. Okay, thanks very much indeed. We've got one question.
Tom Siddle for Four-Way. If I recall correctly, I worked on one of those sites a long time ago when it was an air quality concern again then. Have you got any evidence, whether anecdotal or not, of just how much the signal control can contribute to improving air quality and how much is actually a consequence of the environment? Because I think there you've got a lot of properties which are really right up against the road and you say it's busy and queuing a lot of the time.
We haven't for here, no. It will be interesting to find out. I mean, you worked for me quite a while back. You've stood here with me once or twice. We are interested. Nantwich Road's a funny one. The more space we free up, it seems to be filled more with local cars. John mentioned about prioritising HGVs, and that's something we're eager to look at. The Dunwoody Way one, anything's got to be improvement on the fixed time it was running because of how close the two junctions were together. I'm hoping to be able to stand here in a couple of years' time and answer that question properly for you.
Okay, thank you.
Okay, thanks very much indeed. Thank you.